Let v be the vector represented by the directed line segment from the point 4, 3 to the point 7, -1. Write v in component form and in standard basis form. Let's begin by sketching the vector v. We'll start by drawing some coordinate axes and the 2 points. The first point is the point 4, 3. The second point is the point 7, -1. And so v is the vector who connects the first point to the second point with the arrow pointing at the second point. Notice that to get from the first point to the second point, the vector v had to move 3 units in the horizontal direction and 4 units in the negative vertical direction. That means that the vector v can be written as a change in 3 in the x and a change of -4 in the y. There's the vector v in component form. Remember that the vector can also be written in component form as a column as 3 minus 4. And this would answer part A. As for writing it in standard basis form, remember that the standard basis consists of 2 vectors. The vector I, a unit vector who points 1 unit to the right, and a vector j, who points 1 unit up. If we look at our picture, we see that to get from the first point to the second point, the horizontal change can be represented by the vector 3i. And the vertical change can be represented by the vector -4j. And so the vector v is the vector sum of 3i and -4j. That is, v can be written as 3i plus -4j, or more concisely, as 3i minus 4j. And so we have the vector written in standard basis notation here, and in 2 different versions of component form here.